All right, beginning lesson 37. We are going to go from 4 partial products with our 2 by 2 multiplication to the standard algorithm with using just 2 partial products. Let's go ahead and look at this first problem. It says Sylvie's teacher challenged the class to draw an area model to represent the expression 24 by 56. And then to solve using partial products. This is a little bit of a review. She solved the expression as seen below. Is her answer correct, and why? So, she came up with an area model, it looks like. What did she do with her 24? Well, she broke it into 20 and 4, correct. How about her 56? What did she do with her 56? She broke it into 50 and 6. When she did that, she asked herself in unit form what each one was worth. So she would have said 50 times 4, or 5 tens times 4, which would give me 20 tens. And then 4 ones times 6, which would give her 24, or 4 times 6. Here she would have asked herself 20 times 50, or 2 tens times 5 tens, which is 10 hundreds, and 20 times 6, or 2 tens times 6, which is 12 tens. Here's what she did. She solved 6 times 4 as 24. Is that correct? Yes. Then she solved 6 times 2 tens, which is 12 tens, which is 120. Is that correct? Yes. And then she solved 5 tens times 4, which is 20 tens, which is 200, correct? So you'll see so far we've got 24, 24, 120, 120, 200, 200. So far, so good, right? Let's see how she did next. She did 5 tens times 2 tens and came up with 100. Is that correct? Obviously not, because we can see right here that we have 2 tens times 5 tens, and we got 1,000. So her answer is actually incorrect, because she did not use unit form, 10 times 10. All right, moving on. We're going to use 4 partial products for this, and then 2 partial products. So let's go ahead and draw it out first. It says we have to draw an area model, so we're going to do that. $26 breaks into 20 and 6. 35 breaks into 30 and 5. And we're going to walk through this without having to write all of that other stuff in the boxes. We're just going to say it in our heads to ourselves. 3 tens times 6 is 18 tens, which is 180. 6 ones times 5 is 30 ones. 2 tens times 3 tens is 6 hundreds. And 5 times 2 tens is 10 tens. We can look at it this way. We now have 4 partial products. 6 times 5 ones is 30. 6 times 3 tens is 18 tens. 2 tens times 5, 2 tens times 5 is 10 tens. And 2 tens times 3 tens is 6 hundreds. If I add them all up, I end up with 8, 9, 10, 11, bundle, 6, 7, 8, and 9. So my answer is 910. That's the way we're used to. Now we're going to try 2 partial products. And the way we're going to do this is we're going to break down our problem similarly, except for we're just going to be looking at two partials. So we're only going to have it broken into two groups. I'm going to put a dotted line here, because this is what it was before. So this is going to look like 20 and 6 will still be broken up, but our 35 is going to go straight across the top. So what we're really looking at here is 35 times 6, which is 6 times 5 is 30. 6 times 3 tens is 18 tens, plus 3 is 21 tens. We're looking at this whole section right here is 210. So 6 times 35, 210. Then we're looking at 20 times 35, which if we do 20 times 35, remember, we just ignore that 0. 2 times 5, 2 tens times 5 is 10 tens. 2 tens times 3 tens is 6 hundredths. And that equals 700. So 2 tens times 35 is 700. If I add them, I get 910, just like I got over here. Personally, it doesn't matter to me which way you do it. It's just those are two methods. These two turn into this, these two turn into that. If you can do it in your head, it makes it easier. But if you have to write it off to the side, it's almost like doing this anyway. All right, let's go ahead and see what's next on our list. Let's go ahead and do 43 times 67. We're going to draw an area model again. And this is 4 partials. So 43 breaks into 40 and 3, 60 and 7. If I say 3 times 6 tens, I get 18 tens. 3 ones times 7 is 21. 4 tens times 6 tens is 24 hundreds. Don't get tricked. 4 tens times 7 is 28 tens. What that looks like here is I broke it into components. I did 3 times 7 is 21. I did 3 times 6 tens, which is 18 tens. I did 4 tens, it's in the tens place, times 7 is 28 tens. And last but not least, the hardest one, 4 tens times 6 tens is 24 hundredths. I have the same exact numbers as I had for my area model. And then I add them all up. 1, 8 plus 8 is 16, plus 2 is 18. 4, 5, 6, 7, and 8, and then 2. 2,881. Now if I did it as two partial products, it looks like this. Just that little dot down. To remember that we actually have two parts here. 40 and 3. And then 67 goes along the top. 67 times 3 is like taking these two combined. 3 times 7 ones is 21 ones. 3 times 6 tens is 18 tens, plus 2 is 20 tens. If I added 180 plus 21, I would get 201. This section right here is the same thing. And then 40 times 67. 4 tens times 67. 7 times 0 we don't bother with. 7 times 4 tens is 28 tens. 6 tens times 4 tens is 24 hundredths. Add them up. 2,680. So that's really what this section equals. So when I say 67 times 43 I take that, which is 201. I take that, which is 2,680. I add them up, and I get 1, 8, 8, and 2. 2,881. Same answer, both ways to do it.